Hello, everyone. We are the Demining Autonomous System MQP. Our team is a combination of computer science and mechanical and robotics engineering majors. Our advisors for this project were Craig Putnam, Nicholas Bertozzi, and Marcus Nemitz.
Active landmines are a global issue. Currently, there are over 100 million active landmines globally. Yearly, they affect 20,000 victims, about 80% of whom are civilians. They're most prevalent in countries already struggling to recover from conflict and have significant impacts on the development of infrastructure, trade, and to human life. Demining these areas is imperative to affected communities. Current demining methods are usually manual, using trained animals or armored vehicles. However, all of these have challenges and are generally dangerous, inefficient, and expensive.
Our project goal is a fully autonomous robotic system that identifies and detonates landmines. Compared to other demining methods, it is safe, efficient, and affordable, but does lack some versatility. It starts with an application on a base station computer where a user inputs the boundaries of the minefield to be swept. The rover then goes out and uses a metal detector to exhaustively sweep the region, precisely reporting suspicious bodies and avoiding them before returning home. A drone is then sent out and travels to each location, dropping water balloons to remotely detonate the mines. This MQP has been going on for a few years, and this year saw a lot of change. Let's start by talking about the rover.
Previous iterations of the project used a 6-wheeled Husky drivetrain, but experienced difficulties when turning. To increase the turning ability, we transitioned over to a tread-based drivetrain. The frame was modified to allow for the attachment of the metal detector. An analysis of the stress concentrations and deflections was done on the 4-bar mechanism and attachment components to ensure the design is capable of withstanding the weight of the metal detection system and applied forces during operation. The electrical components of the metal detector drivetrain and communication systems were wired and manual driving capabilities were achieved.
During a test flight last year's drone crashed, so we had the opportunity to purchase a new Terra T-18 octocopter. We designed and 3D printed a dropping mechanism attachment for the new drone. We set up and configured RTK GPS units, but we were unable to install it due to limitations of the flight controller that the T-18 came with. However, we did help the Snow Drone MQP set up there and install their flight controller. We connected a teensy to the new flight controller, allowing us to establish communication between the drone and the base station and actuate the dropper mechanism. And we also set up the new electronic system for the drone.
For the base station this year, we mainly focus on the user interface and the rover pathfinding. In the user interface, we focus mainly on bug fixes in the user interface itself, as well as in the embedded Google Maps API. And then for the rover pathfinding, we actually built an algorithm from the ground up this year to take in a set of boundary points, which it processes, and then return a set of waypoints, which guide the rover to exhaustively search the entire designated minefield.
We'd like to give special thanks to our advisors and everyone else who helped us along the way. Thank you.